The National Electrical Code requires that overcurrent devices, conductors, and other equipment for elevators be sized for the maximum starting current of the elevator motor. This is because the starting current is the highest current that the elevator will draw, and therefore it is necessary to ensure that the equipment is capable of handling this current without tripping or causing damage. The running current of an elevator motor is typically lower than the starting current, and it is therefore not necessary to size the equipment based on the running current alone. However, it is important to note that the running current must still be taken into consideration when selecting the overcurrent device, as it will affect the size of the device that is required to allow normal operation. In a specific case where the elevator manufacturer provides 2 amp values, 121 amps running current, and 278 amps starting current. According to the National Electrical Code, you must size the overcurrent device, conductors, and other equipment for the starting current, which is 278 amps. This means that you will need to select an overcurrent device that is rated for at least 278 amps, and you will need to use conductors that are sized appropriately for this current to avoid overheating and potential fire hazards. It is important to note that sizing the equipment for the starting current will often result in a larger and more expensive installation compared to sizing for the running current alone. However, it is necessary to ensure that the equipment is capable of handling the maximum current that the elevator will draw during starting, and it is therefore worth the additional cost to ensure safety and prevent equipment failure. When dealing with elevator electrical installations, several key factors must be considered to ensure compliance with the National Electrical Code and to provide a safe and reliable system. Firstly, accurately determine the starting and running current requirements of the elevator motor. The elevator manufacturer typically provides these values, and it is crucial to obtain this information directly from them. Secondly, consult the National Electrical Code for specific requirements related to elevator installations. Article 620 covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chair lifts. Thirdly, select overcurrent protection devices such as fuses or circuit breakers that are appropriately sized for the starting current of the elevator motor. The overcurrent protection device should be capable of withstanding the inrush current during starting without nuisance tripping. Consult National Electrical Code Section 430.52 for motor overcurrent protection requirements, keeping in mind any allowances for elevator-specific applications as outlined in Article 620. Fourthly, size the conductors that feed the elevator motor according to the motor's full load current rating, with consideration for the starting current and any applicable directing factors. The conductors must be able to carry the starting current without excessive voltage drop, which can negatively impact the motor's performance and lifespan. Refer to National Electrical Code Table 310.16 for conductor ampacity ratings, and apply any necessary adjustments or corrections based on ambient temperature and the number of conductors in a raceway or cable. Fifthly, consider the voltage drop in the conductors, especially over long distances. Excessive voltage drop can cause the motor to operate inefficiently or even fail to start. Use the appropriate formulas or online calculators to determine the voltage drop based on the conductor size, length, and current. Increase the conductor size if necessary to maintain the voltage drop within acceptable limits, typically no more than 3% for power circuits. Sixthly, ensure that all electrical equipment used in the elevator installation, including the motor, control panel, and wiring devices, is properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories Incorporated or Electrical Testing Laboratories. This ensures that the equipment meets the applicable safety standards and is suitable for its intended use. Seventhly, provide proper grounding for all electrical equipment in the elevator installation. Grounding helps to protect against electric shock hazards and to provide a path for fault current to flow back to the source, which will cause the overcurrent protection device to trip and to energize the circuit. Follow the grounding requirements outlined in Article 250 of the National Electrical Code. Eighthly, install a disconnecting means for the elevator motor that is readily accessible and capable of being locked in the open position for maintenance and repair purposes. The disconnecting means should be located within sight of the elevator motor controller or be capable of being locked in the open position. Ninthly, provide proper ventilation for the elevator motor and control panel to prevent overheating. Motors and control panels generate heat during operation, and excessive heat can damage the equipment and reduce its lifespan. Ensure that there is adequate airflow around the equipment to dissipate the heat. Tenthly, conduct a thorough inspection and testing of the elevator electrical installation after completion to verify that it is installed correctly and that it meets all applicable code requirements. Testing should include insulation resistance testing, continuity testing, and voltage and current measurements. Correct any deficiencies that are found during the inspection and testing process. 11thly, maintain accurate records of the elevator electrical installation, including wiring diagrams, equipment specifications, and test results. These records will be helpful for future maintenance and troubleshooting. Regularly inspect and maintain the elevator electrical system to ensure its continued safe and reliable operation. Finally, it is also important to consider the specific requirements of the local electrical code and any applicable building codes. These codes may have additional requirements that must be followed in addition to the National Electrical Code. Consulting with a qualified electrical engineer or a licensed electrician is highly recommended to ensure that the elevator electrical installation meets all applicable requirements and is installed safely and correctly. They can provide valuable guidance and expertise to help you navigate the complexities of elevator electrical design and installation. Furthermore, the type of elevator being installed, such as traction or hydraulic, can influence the electrical requirement. Traction elevators typically require more sophisticated control systems and may have regenerative braking systems that can feed energy back into the building's electrical system. Hydraulic elevators, on the other hand, typically have simpler electrical systems but may require larger conductors and overcurrent protection due to the high starting current of the hydraulic pump motor. It is also essential to coordinate the elevator electrical installation with other building systems such as the fire alarm system and the emergency power system. Elevators are often required to have emergency power backup to ensure that they can continue to operate during a power outage. The fire alarm system may also be integrated with the elevator control system to automatically recall elevators to the ground floor in the event of a fire. In addition to the technical aspects of elevator electrical design and installation, it is also important to consider the safety of personnel working on or near the equipment. Elevators are complex machines with many moving parts, and there is a risk of injury if proper safety precautions are not followed. Only qualified and trained personnel should be allowed to work on elevator electrical systems, and they should always follow lockout/tagout procedures to de-energize the equipment before starting any work. Personal protective equipment, such as safety glasses, gloves, and insulated tools, should be used to protect against electrical shock and other hazards. Regular safety training should be provided to all personnel working on elevator electrical systems to ensure that they are aware of the potential hazards and how to mitigate them. In summary, designing and installing electrical systems for elevators requires a thorough understanding of the National Electrical Code, elevator-specific requirements, and safety best practices. By carefully considering all of these factors and consulting with qualified professionals, it is possible to create a safe, reliable, and code-compliant elevator electrical installation.